Okay, Algebra 1, we are moving on to section 2.6, solving absolute value equations. So what I've done at the top here is I have outlined 3 steps that you need to follow when solving these equations. So the first is use inverse operations to get the absolute value by itself. Now, I'm going to clarify what that means right now. So the absolute value, if you look at these first 4 examples, the absolute value is the absolute value and whatever is inside of it. So on this one, it's just the x. On this one, it's the x plus 2. On this one, it's just an x. And this one, it's right here. So that's what I mean by absolute value. Then the second step is to rewrite the equation as 2 cases that do not involve absolute value. And the third step is to solve the equation in each of the 2 cases. So the first question you ask is, do I have the absolute value alone? Yes, there's nothing with that x there. Rewrite the equation as 2 cases. So I will do case 1. And that is just x equals 4. Case 1 looks exactly the same. Case 2, though, what we have to change is whatever is equal to the absolute value is negative. So it's not positive 4, but it's negative 4. And then in this particular one, the third step would be to solve, but is there anything to solve for? No. So these are your answers. So in all of these problems, you're going to get 2 answers, or in most of these problems, you're going to get 2 answers, because I want you to think about this. If I put a 4 into the absolute value, I would get 4. And if I put a negative 4 in for the absolute value, I would also get 4. So there are 2 possible answers that give you the same answer. And that's why we have to make our 2 cases, one with a positive, one with a negative. So, next problem. The first step says use inverse operations to get the absolute value alone. Is the absolute value alone? It's not, because we have a 4 outside here. 4 is being multiplied by the absolute value, so how do you undo multiplication? Well, we are going to divide. And then you're left with the absolute value of x plus 2 equals 24 divided by 4 is 6. So your next step is to make your 2 cases. Case 1, you just write it just like it is, but you drop that absolute value. Case 2, you write it as it is on the left-hand side, but whatever that absolute value is equal to, you make negative. Okay, final step. Now we actually have to solve. So I'd subtract 2 from both sides on this side. We have x equals 4. And I'd subtract 2 from both sides on this one, and we have x equals negative 8. And I'm just going to show you how this works. We can test by putting these answers. We have x equals 4 and x equals negative 8. So if I go back to my original equation, I'm just going to show you why this works, because the more examples you see, the easier this is to kind of make sense of. And so what you're going to do is you're going to do 1 with the 4 in there. 4 plus 2. I'm making those absolute values really large so you can see. And this is just kind of for a visual here. Okay, so just like order of operations, you have to do what's inside that absolute value first. So 4 plus 2 is 6. Well, the absolute value of positive 6 is just 6. What's 4 times 6? 24. Does 24 equal 24? Yes. On the other side, though, negative 8 plus 2 is negative 6. What's the absolute value of negative 6? Positive 6. What's 4 times 6? 24. Does 24 equal 24? It does. So what happened is that there were two possible answers that allowed us to arrive at a 6 and a negative 6 that became positive and then made our equation true. So that's why we get two different answers. Okay, so going to letter C. Is the absolute value alone? It's not. So the first thing you do is move that 3 to the other side by addition. So I get the absolute value of x equals 7. Case 1, the equation looks exactly the same. You just drop that absolute value. Case 2, we put a negative with that 7. Now if there's nothing to solve, that is your final answer. So sometimes they're just opposites, like a negative and a positive, positive, negative, whatever. But then other times they are not. So just pay attention. You can't just, some people want to just put a positive 7 and a negative 7, but that doesn't always work. Okay, so now another problem. Use inverse operations to get absolute value by itself. Is it by itself? It is. So we can jump right to our two cases. Now, in this particular one, the 8 is on the other side. Doesn't change anything, but the 8 is what we have to change, positive or negative. So the first equation looks exactly the same. The second equation, I have to make it a negative 8. Now I have to solve by addition. So this gives me a 10.5 equals x on this side. Then I add 2.5 on both sides on this one. So remember, if you have a positive and a negative, you're technically subtracting. So this is kind of like taking 8 minus 2.5. So I end up with a negative 5.5 equals x. So you get two answers for this one. Okay. So we do have some special cases. And those special cases I'm going to show you. Some of you are going to be really good at picking them out before you even have to solve your whole problem. And then some of you might have to wait until you get to kind of the end. You can still follow the same steps. So the first step is to get the absolute value alone. So first I have to move that 4 over. Now I have the absolute value of x plus 3 equals 0. And I'm going to make my two cases. Case 1, case 2. Okay, so case 1, remember I said the equation stays exactly the same. You just drop the absolute value. But case 2, I have to make it negative. So my question for you is, can you have a negative 0? No. So in this problem, when you have your absolute value equal to 0, you're just going to get one answer. Okay? So you're going to go through and you're going to solve this. Minus 3, x equals negative 3. So you can only get one answer for these types of problems. I just put a little note in there. Only one answer because the absolute value equals 0. Okay, in letter F, you are going to get the absolute value alone first by subtracting that 8. So I get negative 3 equals the absolute value of x plus 2. So some of you guys should notice right now why this is a special case. Let's take a peek at it for a second. Most of you will not notice this until you go to make your case 2. Because when you go to make your case 2, you're supposed to make the number a negative, but it's already negative. Okay, so I'm going to put a little note here. Already negative. Oh, I can't spell. Already negative. Stop. Absolute value cannot be negative. So in this situation, when you have your absolute value equal to a negative, it's a no solution. Because any number you put in here, doesn't matter if it's positive or negative, is going to create a positive value, so it can't be negative. Okay. Letter G. We're going to do a couple more practice of these ones. So this one, I would move my 2 to the other side. But what's tricky is I still have a negative out in front. So remember that when these are kind of like parentheses, so if I have a negative here, there's technically a 1. So I could divide both sides by a negative 1. And then this should be a red flag for you, that this is a no solution. Because the absolute value cannot equal a negative. Okay, one more. You want to get the absolute value by itself, so we're going to add 6. X minus 4 equals 0. When you go to make your 2 cases, like I said, this is where a lot of you will notice it. That's kind of why I'm going through these motions. Case 1, x minus 4, oops, I should drop that, equals 0. Case 2, there's no case 2 because it's equal to 0. So you can just solve this by adding 4 to both sides. X equals a positive 4. This is the only answer. Okay, so the Sydney Harbour Bridge in Australia is 1,149 meters long. Because of the changes in temperature, the bridge can expand or contract by as much as 420 millimeters. Now, a millimeter is not very much. 420 millimeters, it's a little bit more, but it's about, if you think of every 10 millimeters as a centimeter, and so if you divide this by 10, it's 42 centimeters, okay? So this is a really large bridge, but it does have some change with temperature. So it says rate and solve an absolute value equation to find the minimum and maximum lengths of the bridge. So these are pretty tricky, but I'm going to give you an outline that you can follow every single time. Okay, so if I have an absolute value here, the x minus, and then this is going to be, I gotta think about this, the desired number. has to be equal to the amount of change. So in this case, our desired number is we want that bridge to stay at 1,149 meters, okay? So it's going to be x minus 1149. The amount of change is how much that bridge is going to expand or contract. The one thing here, though, I have to put it in meters. So this is actually going to be 0.42. And the reason is because this is in millimeters. So in centimeters should be 42. Oh, I should double check that. 420 divided by 1,000. There's 1,000 millimeters in a meter. Okay, so now we can solve this by doing our case 1 or case 2. I'll do that off to the side here. Case 1 is x minus 1149 equals 0.42. And this is case 1. And case 2 is x minus 1149 is equal to negative 0.42. So then we solve it by adding. So our x equals 1149.42. And then when we subtract this, it would be x equals 1148.58. So it says the minimum and maximum lengths of the bridge. Well, if the bridge contracted, it could be as short as 1,148.58 meters, and if it expanded, it would be as big as 1,149.42 meters. So it's important, these absolute value expressions are actually very important when people are building things or manufacturing things, and they refer to these as tolerances a lot of times, but the cool thing is with absolute value, it can be programmed in there.